In our previous video, we talked about surfactants and emulsifiers and stabilizers, and in the video before that, we talked about shearing power and why a sauce would coalesce or break on you. So we're going to finish our emulsification video series by just walking through the actual emulsification process to put some of these things into perspective. So here I just have my normal metal mixing bowl, and in this example, let's go ahead and walk through the basic steps of making a mayonnaise. So to this metal mixing bowl, to make my mayonnaise, I'm going to classically add lemon juice, but this could technically be any sort of vinegar or acid that you like. And then to this, I'm also going to add egg yolks. And so because I'm using a metal mixing bowl, the most logical application of shearing power or shearing force would be a whisk. So here I have my nifty orange whisk, and I'm going to whisk the egg yolks and lemon juice together, and that's going to look something like this. They're going to mix together, and the yolks and the acid are going to be my continuous phase. And this continuous phase will be considered water, right? And this sometimes it gets a little confusing only because we all understand that egg yolks do contain fat, but they are pretty much always considered to be the water phase of an emulsification. And so you're going to go ahead and drop in your fat into your water or to your continuous phase. So this will be a fat dispersed into water emulsification. So here I have my fat droplet, and you're going to add the fat very slowly at first. And this is because there's a lot of area for that fat to run and hide from the whisk, right? So the whisk needs to be able to break this up and emulsify it in. So as you start to continue to whisk around the bowl, you can add a couple more drops here and there as they start to incorporate, and eventually the fat will break up into smaller particles and look something like this. Now once you get the fat dispersed and your emulsification is going, and the way that you know that it's dispersed is number one, it's going to come together, and also you're going to notice that the emulsification will start to thicken slightly. And at this stage, when it starts to thicken, you're going to have a bunch of little fat particles dispersed throughout your continuous phase. And when you add your new fat droplet, something kind of cool happens. So here's our new fat droplet, and we'll color it dark green so we can keep track of it. When you add this new fat droplet, you continue to whisk it around your bowl, and it starts to knock in or bump into all of these other already small dispersed fat particles. And as this happens, it will actually be broken up by just the force of knocking into each other. And what happens is as they start to knock into each other, the already dispersed fat is going to help to break up the new fat and disperse it more evenly into smaller particles throughout the emulsification. And this is something that Harold McGee calls the fat mill in his book on food and cooking. And we're going to label it the dispersion mill because technically speaking, this could be this works with both, just any dispersed phase, whether your dispersed phase is fat or whether it is water. This dispersion mill holds true, right? So the more emulsified fat that you add, the more viscosity you will have, or the viscosity will increase. And when we talked about last episode, viscosity in and of itself can actually work as a stabilizer. And this happens because the more viscous or the thicker your emulsification becomes, you will have more increased drag on your dispersed phase, in this case the fat particles. And as these fat particles have increased drag on them, they will start to split up into a smaller dispersed phase. The shearing power will actually increase, and the emulsion by nature will become more stable because you have a smaller dispersed phase. And because of the viscosity acting as a stabilizer, and because of the already dispersed fat acting as our dispersion mill, towards the end of the emulsification process, you can actually add the fat more quickly. Now that we understand the actual emulsification process, let's talk about real quick some emulsion formulas and ratios. And the way that we're going to do this is this chart is going to be available for you in the show notes. And I have it organized by the name of the sauce or the emulsification. Continuous phase, dispersed phase, emulsifier, water to emulsifier to fat ratio, and shelf stability at normal serving temperature. So let's take hollandaise real quick as an example. Your continuous phase is going to be egg yolk and vinegar, or lemon juice, whatever you like. The dispersed phase is classically clarified butter, but you can add any fat that you like, technically speaking. Emulsifiers are the egg yolks, right, which are lecithin and casein. And so for the water to emulsifier to fat ratio, you can see I made a little notation. Yolk equals emulsifier. And all these ratios are always going to be done by weight. So for every 1 part of vinegar you have, you want to add that equal amount by weight, egg yolk, and then 5 parts of clarified butter. And that will give you hollandaise. And this is more, I mean, looking at this chart is more of a reference for you. We have a whole lecture series on hollandaise sauce in the Stella Culinary School podcast. So if you're unfamiliar with actually how to make hollandaise sauce, you can listen to that. And so this, you can just use this to cross-reference for basic ratios, and also it'll help you understand how certain emulsifications act. So, for example, look at the vinaigrette column. So vinaigrette, your continuous phase is actually oil, and your dispersed phase is vinegar, which makes this a water dispersed into fat, or a water in fat emulsion. And they're normally unstable unless you add mustard or some sort of food-grade gums. Another thing that I want to draw your attention to real quick before we move on is sauce vierge, because sauce vierge, and I will link a recipe in the show notes, is the continuous phase is tomatoes ground up with vinegar, and this is a good example of using plant particles as an emulsifier. So this chart will be in the episode show notes for this emulsification series. And so to find further information on this and linked recipes and linked technique videos, go to stellaculinary.com/FS1, and FS stands for food science. And even though this is a 3-part video series, FS1 will take you to a page that will have all 3 videos with some extra information. And in this show notes page, you can also take an emulsification quiz to test your newfound knowledge. I will make this presentation into a PDF that you can download and use as a study guide. And also I will make this actual presentation, which I've done in Keynote, available for both download in Keynote and PowerPoint format. And this is for personal use or for nonprofit educational uses only. So if you teach in a public school and you want to talk about emulsifications, you are more than welcome to go to stellaculinary.com/FS1 and download this PowerPoint presentation, and you can teach emulsifications. If you are a for-profit culinary educator, go ahead and contact me, Jacob at stellaculinary.com, and we'll work out some sort of licensing deal.